Hi, welcome to Math Minute. My name is Adam, and today we're going to be talking about marginal cost and marginal revenue. Now, with marginal cost and marginal revenue, we're trying to figure out how much of an increase or decrease in cost or revenue we'll have by increasing production. So, let's remember what a derivative was way back when at the beginning of the class. When we actually find a derivative of a function, we're finding the slope of a line. We're finding how much we're going to increase or decrease by increasing the x value, or in this case, the quantity. So if we're actually applying that now, we're going to try to find out how much more money we can get by increasing or decreasing our amount of production. So we'll start off with marginal cost. Marginal cost is going to tell us the amount of increase of cost by increasing the quantity. Now we can also get a decrease out of this. So we're going to try to figure this out and go from there. So marginal cost is just labeled MC equals the derivative of cost. So once again, the margin is just the derivative. So there's another phrase for this, and it's called the additional cost at the margin. So now if you see here, I have this written, MC is approximately C at Q plus 1 minus C at Q. Now that should look pretty familiar. It should look like if we estimated a derivative at the very beginning of the class. Now if you remember this, we took 2 points that were very close together, and we found the slope between the two. So we're finding the slope between the point Q plus 1 and Q. We're going to find it when x equals Q plus 1 and x equals Q. So now if you notice, down here, we're just going to have Q plus 1 minus Q. So this actually equals C at Q plus 1 minus C at Q over 1. So this is an approximation again. So now what that does is we've basically just found the slope between 2 points, or in other words, we've estimated the derivative, and in turn we have estimated the marginal cost. So when it says that MC is approximately C at Q plus 1 minus C at Q, that's just estimating the derivative. That's all we've done at the beginning. So if you notice, marginal revenue is the same idea. We take marginal revenue, we abbreviate it the same way, MR, and that equals the derivative, R prime of C, or this should be Q. So now this is in the same way, approximately R at Q plus 1 minus R at Q. We're taking the slope between 2 points very close together, and the denominator happens to be 1 because they're 1 unit apart. So now we've talked about marginal cost and marginal revenue, but let's actually apply it. Let's use this towards something like profit, because that's actually really helpful. So for some of the applications, if the marginal cost equals the marginal revenue, we've maximized profit. So how that looks on a graph is at this point right here. The marginal cost equals the marginal revenue. The slopes are the same. So if you notice, if you can kind of make a connection, this space is as large as it's going to get. The distance between the two, the cost and the revenue, is as far as it will be at that point. So that's why we maximize profit. We'll talk about that more in a later video, but all you need to know is that when marginal cost equals marginal revenue, you've maximized profit. Probably something you've heard from economics, but now you can see it from calculus. So another idea is if marginal cost is greater than marginal revenue, we do not want to increase production. So what that says is if the slope of the cost function is greater than the slope of the revenue function, we don't want to increase to another unit. Because if you notice here, this distance is going to be greater than that distance. So by increasing 1 unit or increasing production by 1, we're going to actually decrease our profit. So that doesn't make sense. Now on the opposite end of the spectrum, if the marginal cost is less than the marginal revenue, we're going to want to increase production to the next unit, because what that does is it increases that space between the two. And as you know from what the first idea was, we maximize profit when the marginal cost equals the marginal revenue. What that does is it gets the distance between revenue and cost to be as great as we want, as big as it can be. So that's kind of an easy idea to understand, that maximized profit is when revenue is greater than cost at its greatest distance between the two. So this has been marginal cost and marginal revenue. It's kind of made the connection to profit and how the distance between the two functions really helps us. And if the slopes equal the same, we can maximize profit. So hopefully it's been helpful, and we'll see you next time.